Hi, this is Kate, and we're writing equations of lines. Claire is ready to do some painting. She's going to paint the upstairs hallway for her mom. She'll charge her mom $30 for the supplies she bought, plus $12 for every hour she works. So if it takes her 1 hour, she'll end up charging her mom $42. If it takes her 3 hours, that's $36 for the labor, plus $30 for the supplies, so she'll charge her $66. Which of these pairs of hours worked and dollars charged fits our situation? If Claire works 9 hours, she'll charge her $108 for the labor, that's 12 times 9, plus the $30 for the supplies, so she'll end up charging her $138. If Claire's mom wanted to know how much she'll pay for any number of hours of labor, she would multiply the hours by 12 and then add 30. We can say this algebraically if we use a variable h for hours and a variable d for dollars. The quickest way to get a sense of the relationship between hours and dollars is to graph it, because this will tell us all the different combinations. So our graph should reflect that 9 hours of work will cost $138, that 3 hours of work will cost $66, and that 0 hours of work, if she just paid for the supplies, would cost $30. All of these pairs of values will fall on a line. Which position on the graph corresponds to 12 hours of work? Choice D corresponds to 12 hours of work. We needed to look along the horizontal axis, the blue one, find 12 hours, and then follow it up. Use the graph and what you know about slope to find the slope of this line. The slope of the line is 12. We could use any 2 points on the graph, but I'm going to use the ones that I marked to compare the rise and the run. Slope is the vertical change divided by the horizontal change. Between these 2 points, the rise is 60 and the run is 5. That tells me the slope is 60 divided by 5, 12. So look at the equation that we wrote. The slope of the line, 12, is right here. It's how much the dollar value changes for every additional hour of work. How about the 30? Where's the 30 located on the graph? Can you find it? Is it the number of dollars that are charged for 0 hours of labor? Is 30 where our graph crosses the d-axis, the vertical red axis? Could we think of $30 as the starting value of this relationship? Or is it really all of these choices? What do you think? All of these descriptions are a good way to think about the 30. It's right here. It's where it crosses the vertical axis. It's the starting value of the relationship. And it's how much money Claire's mom pays for just the supplies for 0 hours of labor. We can think of the 30 as where the line begins, and the 12 as the movement of the line. The 30 is already on there. By movement, I mean if we work this many hours, we charge this many dollars. It's how fast it increases. It's typical to call that starting value B, and the movement value, the slope, M. It's also very common to call the horizontal change X and the vertical change Y. I could write the equation like this, B plus MX equals Y. Since addition is commutative, this means the same thing, MX plus B equals Y. The most common way to see the equation of a line written is like this, Y equals MX plus B, but we really just rearrange things. M is the slope of the line. You can also think of it as the movement of the line. And B is the beginning value. It's also where it crosses the y-axis. It's often called the y-intercept. Observe the graph of this line. Can you choose an appropriate equation for this line? Choice D is an equation of this line. 5 is the y-intercept. We look for that right there, where it crosses the y-axis. -1/3 is the slope. If we take any 2 points and compare the rise and the run, we end up with -1/3. I'll use these 2 points. To move between them, if I go down 4, I have to go over 12. -4 divided by 12 reduces to -1/3. Is the point 51, -12 on the line y equals -1/3 x plus 5? Well, wait a minute. That was the graph we were just looking at. Is that point on this line? Well, 51, -12. 51's all the way over here, and then down 12. It's kind of hard to tell from the graph. But remember, this equation, y equals -1/3 x plus 5, is shorthand for all the different xy pairs that fall on the line. If any set of numbers, x and y, make this equation true, then the point has to be on the line. 51, -12 is an xy pair. So grab a pencil and some scratch paper and see if you can figure out if this point is on this line. (51) -12 is on the line. If we take our y equals -1/3 x plus 5, substitute in -12 for y and 51 for x, 1/3 of 51 is 17. It works out that the equation is true. The left side equals the right side, so we know the point is on the line. Write the equation in y equals mx plus b form of the line with slope 8 that passes through the point -1, 2. When you think you've got it, choose the best answer. The equation of this line would be y equals 8x plus 10. We start with y equals mx plus b form. The problem tells us that the slope is 8, so we'll substitute in 8 for m. We still need to find the y-intercept, so we're going to use the point that we know is on the line, -1, 2, and substitute those in for x and y. 8 times -1 is -8, and then we can add the 8 to both sides to determine that the y-intercept is 10. Therefore, the equation of the line is y equals 8x plus 10. Write the equation of the line that passes through the points, 10, 11, and 12, 12. So they don't tell us the slope this time. All we know is 2 points that are on the line. Our answer eventually will look like this, except we need to figure out numbers for m and b. So the first order of business is to find the slope. Would you already know how to find the slope if you're given 2 points on a line? Go ahead and find the slope now. The slope is 1/2. To find the slope given 2 points, we subtract the y's, subtract the x's, and divide them. This gives us a slope of +1/2. So we know our slope will be +1/2. We can substitute that in for m. Now we need to find the y-intercept. See if you can figure it out. The y-intercept is 6. We need to substitute in one of those points for x and y. It doesn't matter if we substitute in a 10 and an 11, or if we substitute in a 12 and a 12. I chose to sub in 10 for x and 11 for y. 1/2 of 10 is 5, then subtract 5 from both sides, so the y-intercept is 6. The equation of this line is y equals 1/2 x plus 6. This is Kate, and you've been writing equations of lines.